In this video, we are going to be investigating the energy content of food. And I'm going to be doing that using crisps. So what I want to know out of a Dorito, a cheese puff, and a Pringle, which of these three crisps has the most energy? Food is a source of chemical energy, so I want to know which has the largest store of chemical energy. This is a diagram of how I will carry out that investigation. So here I've got a needle on a wooden handle, and I'm going to put the crisp on the needle and I'm going to light the crisp so it will be on fire. Above that is going to be a test tube of water. The chemical energy in the crisp will be transferred using thermal energy to increase the thermal store of the water. So I want to know which crisp transfers the most thermal energy, because that will tell me which crisp had the most chemical energy to start with. So I'm going to measure how hot this water gets for the different types of crisp. So before I start the experiment, I need to make sure that I have planned my variables. So the independent variable is the variable that I am going to change. And every time I change this experiment, I am going to change the type of crisp. That's what I'm going to investigate. The dependent variable is the variable I'm going to record and measure. What am I going to write down in the results table? I am going to write down the change in temperature of the water. And then so that I can get valid results, I need to have control variables. You're only allowed to change one thing. So I'm only allowed to change the type of crisp. Everything else I must control and keep the same. So if we look here, 10 centimetre cubed of water, I'm going to keep the volume of water the same. The crisp should always be 5 centimetres away from the test tube. So I'm going to keep distance between the food and the boiling tube the same. Now I've got a plan of my variables, I can show you the experiment. Here I've got some of the equipment I'll be using today. We've got safety goggles to protect our eyes from the hot crisp and the potentially hot water. I've got a measuring cylinder to measure 10 centimetre cubed of water, which will then go into the boiling tube. I have got a heat-proof mat to make sure I don't burn the desk, and I have got a thermometer. I'm going to take the temperature of the water at the start. I'm going to burn the crisp underneath the tube. I'm going to take the temperature of the water at the end, and then I'm going to calculate the difference. This is the table I'm going to use to record my results. So the first crisp I'm going to do is the cheese puff. So food type is cheese puff. And then test one, I need the start temperature, the end temperature, and then I can calculate the increase. There is, however, one thing missing from my results table. A results table always needs units. So the temperature is measured in degrees Celsius. I've taken the start temperature of the water, it was 21 degrees, and I have lit my splint ready to set my first cheese puff alight. So here we go. Hopefully it will catch fire. There we go. The flame has now gone out, so I put my crisp down onto the heat-proof mat and I record the temperature. I'm going to lift it off the bottom of the boiling tube so I don't get the temperature of the glass. I want the temperature of the water, and that has gone up to 25, 26, 27, 28 degrees. So in my results table, it started off at 21 and it's gone up to 28. What I'm going to do now is change the boiling tube and change fresh water so it's cold again, and do my cheese puff, well, do another 2 cheese puffs to get my repeats. I'm now set up ready to do the second type of crisp. I'm going to use the Pringle. So let's try and light Pringle. There we go, that's caught. Let's try and light it here as well. Much bigger flame this time. Okay, the flame has completely died out, so I need to quickly take the temperature of the water, and that has gone up to 52 degrees. So the start temperature was 22 and that has increased to 52. Okay, so I have got fresh cold water and a new boiling tube, so we have gone back down to room temperature and I'm ready to test my last crisp, which is a Dorito. Okay, the crisp has finished burning and I can actually see the water inside the tube has started to boil. If I check the temperature, that has gone up to 91 degrees. So I'm going to add that to my results table and do 2 more Doritos to complete my repeats. Here I have my completed results table. It got a bit wet, but that's what happens when you're doing an experiment. So I've got a start temp and an end temperature, and what I need to work out is the increase. So from 21 to 28, what is the increase? And that is 7. So it's increased by 7 degrees. Now I have completed all the increases in temperature, I am ready to work out the average increase. And to do that, I'm only looking at the 3 increase columns. So this one here, and this one here. And I only want to look at 1 crisp at a time. So I'm going to check for anomalies. So I've got 7, 9 and 9. Those 3 results are quite close together, so there are no anomalies. So to work out the average, I do 7 plus 9 plus 9, and I can divide by 3 because I have used 3 numbers. Then looking at the results for the Pringle, got 30, 30 and 33. Those 3 results are close together, so there are no anomalies. To work out the average, I add 30 plus 30 plus 33, and I divide by 3 because there are 3 values. For the Doritos, I have 69, 73 and 28. This 28 does not fit the pattern, so I'm going to circle it and I'm going to label it anomaly. Now, anomalies don't get included in your average results. So to work out the average here, I do 69 plus 73 and I divide by 2 because I'm only using 2 of the values. That will give me my average. You do not include an anomaly when you are working out your average. Once you've worked out your averages, you can clearly see which of the crisps has got the most chemical energy.